Alright, this video is going over the first free response question, which was from test 1987, number 3. So hopefully you went through and realized that this is a conditional probability question where you needed to set up a probability tree. The reason is because we have two events that are affecting each other, which means it's conditional probability. So even though it was listed second, the event that you should have had first on your tree, because it makes sense that it should go logically first, is whether a randomly selected person actually has the disease or not. Okay? And the reason that we put this one first is because that's going to determine the probability that they test positive or negative. So that's why we have to put that one first. So we're going to put whether they actually have the disease or not. And you can see that last sentence says about 2% of the population actually has the disease. So our two choices, yes or no. Yes, they do have the disease, and no, they don't. We're going to put 0.02 for they actually do have the disease, and 0.98 for that they don't. Remember, we get that 0.98 by subtracting it from 1 to get the inverse probability. Then our second event is that you get a positive result. So if you have a positive result, it tells us that first, people that don't have a disease get a positive result 5% of the time. So that's where we get this side of the tree right here. Sorry about that. So that's where we get this part of the tree, because it tells us that people that don't have disease test positive 5% of the time due to an error, which means that 95% of the time people that don't have the disease are going to test negative. Now, the next sentence says a negative result leads to a 0.3% chance. It gives a negative result 0.3% of the time for people who actually have the disease. So if you actually have the disease, that means that it's going to test positive 99.7% of the time, and then 0.3% of the time, or 0.003, is going to be negative. And those are our only two events. So once we have our tree set up, we can answer our questions. So A says, what's the probability that person selected randomly would test positive for the disease? So if we look at our tree, we have two different possibilities for testing positive. People that actually have the disease and test positive, and people that don't have the disease and test positive. So to get that probability, remember we multiply down. So we do 0.02 times 0.997, which gives us this probability right here. And then for the other side, we do 0.98 times 0.05, and that gives us 0.049. So those are the two different scenarios where we could get a positive result, where we actually have the disease and test positive, or you don't have the disease and still test positive due to an error. Now, if you look here, if you're test positive, you're more likely to actually not have the results, not actually have the disease, because you're dealing with so many more people that don't have the disease. That's why that number is going to be higher. Okay? So again, the question is asking, what's the probability that number randomly selected person would test positive? So what we're going to do is add both of these numbers together. Okay? So we do 0.01994 plus 0.049 equals 0.0989. Okay? Because another way of saying that, what's the probability that they test positive and actually have the disease, or they test positive and have a negative disease? So that or word's going to connect them. We add them together. All right, so you should have had 0.0689 for your answer for parts A. Now for part B, it says, what's the probability that a randomly selected person who tests positive for the disease does not have the disease? So for this one, we set up our fraction, and our denominator is going to be the total amount. So the denominator is going to be the total amount. So we're given a restriction here, a randomly selected person who tests positive. So 0.0689% of the people test positive, so that's going to go as our denominator. Then our numerator is going to be the percent of people who test positive who don't have the disease, which is this number right here. So we put that on top, and we divide those numbers to give us 0.7112, and that's going to be your probability. So again, just make sure you're taking the time to draw these. If it's conditional probability problem, draw the tree. It's going to help you solve the questions a lot easier than if you're trying to do it without the tree.